Welcome back. In this series, we'll look at the carboxylic acids. Carboxylic acid, they have the general molecular formula CnH2n plus 1 COOH. And the first member of this series is methanoic acid, which has only one carbon atom. N is equal to 0. So if you check if N equals to 0, it means the first carbon atom is no longer there. So because it's going to be C times 0, and then H2 times 0 plus 1 COOH, and then C times 0 is 0, so that is not there. And then H2 times 0, that is 0 plus 1, 1, so that is H1, so we can just write H and COOH. So this is the formula for, this is the molecular formula for methanoic acid, the first member of the carboxylic acid group. So the second member is when N equals 1, and that is going to be ethanoic acid. So if N equals 1, so it means we are going to have C1, H2 times 1, 2 plus 1, 3, and then COOH, which is going to be CH3, COOH. This is ethanoic acid. And the third family member is when N equals to 2. So if N equals 2, it means we're going to have C2, H5, COOH, and that will be propanoic acid. And when N equals 3, so that's going to be C3, H7, COOH. So we have 4 carbon atoms. Remember, 3 here and then 1 here, making 4. That is going to be butanoic acid. Here we have 3 carbon atoms. Remember, 2 here and then 1 here. Then we have propanoic acid. 1 here and 1 here. We have ethanoic acid, and just only 1 carbon atom here. So we have methanoic acid. So just like others, the chain length increases from the smallest member of the family to the next and the next member of the family. So in that case, the boiling point of methanoic acid will be the smallest compared to the rest of them. So methanoic acid is 101 degrees centigrade, and it is 118. And then the next one, which is propanoic acid, is 141. And then the next is 164 degrees centigrade. Remember, the functional group is COOH. So let's focus our attention on ethanoic acid, which is the commonest member of this family. Remember, when we're talking about ethanol, we discussed 2 ways of making ethanol. So remember, we said we can make ethanol by reacting ethane with steam, and we can also make ethanol by fermentation. So there are 2 ways of making ethanoic acid as well. So whether we use the first way or the second way of making ethanoic acid is made by oxidation of ethanol. So let's write that equation first. So it means our starting material is ethanol, undergoes oxidation. So how do we show that the reaction is oxidation? So we just put O in square brackets on top of our arrow, showing that this is an oxidation process, and then the product is ethanoic acid. Remember, ethanoic acid will have 2 carbon atoms, and one of the carbon atom will carry the functional group. So we have CH3 already, and then the functional group is going to be CO, that is carbon to oxygen double bond, carbon to oxygen single bond, and then to OH. So this is our ethanoic acid. Ethanol is C2H5OH, and ethanoic acid is CH3COOH. Let's now look at those 2 ways. We said those 2 ways involve oxidation of ethanol to give us ethanoic acid. So let's look at the first way. So the first way to make ethanol is using an oxidizing agent, and this is the chemical way. So the oxidizing agent used in this reaction is potassium manganate 7 in the presence of acid. Sometimes they can call it acidified potassium manganate 7. So if you remember, oxidation and reduction reaction involves two reactants, oxidizing agent and reducing agent. So when we are making ethanol using an oxidizing agent, our oxidizing agent is potassium manganate 7 and our reducing agent is ethanol. So the potassium manganate 7, which is the oxidizing agent, will oxidize ethanol to ethanoic acid, and ethanol will also reduce our potassium manganate 7 to manganate 2. So what the IGCSE needs from you in this reaction is to be able to write ionic equation for this reaction and then to be able to indicate the color change, because the color change will let you know that the ethanol has actually undergone oxidation. So let's write the ionic equation. So remember, potassium manganate 7 is written as KMnO4. So the ion that participates is just MnO4 ion, and then we write it as MnO4 minus. Then remember we said it is acidified potassium manganate 7. That is, we said the reaction takes place in the presence of acid. So you need to indicate the presence of acid in that reaction. So how do you do that? You just write plus. H plus. The hydrogen ion here indicates that the acid is present in the reaction. And then you write the product of the reaction, which is Mn2 plus water, which is H2O. We know that our reactant is MnO4 minus, and then our product is Mn2 plus, and the reaction happens in the presence of acid, so we add H plus here, and because we add acid, because acid is present in the reaction, the product will also involve H2O. And then we need to balance this equation. Balancing this equation needs balancing atom-wise and charge-wise. But I don't want to mention that because that is not mentioned in IGCSE curriculum. So let's balance the hydrogen atoms. So we have one hydrogen atom here, and then we have two hydrogen atoms here, and then we have four oxygen atoms here. So since we have four oxygen atoms, let's put 4 here. So the oxygen is balanced, and that makes hydrogen to be 8. So we'll put 8 here. So by putting 8 here, I think I need to mention it, because if I just write the electrons, you will not understand where the electron comes from. So we have balanced this equation in terms of atom. So what about balancing the equation in terms of the charge? So you just look at the charge here. Minus means -1, and then 8 plus means +8. So at this side we have -1 and +8 charge. So when we add them together, the total number of charges here is +7. So if we look at the other side here, we have only 2 plus, that is +2. Here there is no charge with water, so it means this side we have 2 plus, and this side we have 7 plus. When we are balancing charges, we add electrons. So we have +7 here, and then we have +2 here. So if you add, remember electron means -1. So if you add electrons here, that is 2 minus 1, this one will become 1. So we are not adding electron to this side. Let us add our electron to the side that has the highest charge. So when you are balancing by adding electron, you add your electron to the side that has the highest charge. So if you add 1 electron here, it means -1. So this one becomes +6. So we are going to +2. We want this to be +2, and this is +2. So it means we are going to add 5 electrons. When we add 5 electrons, this will become what? Plus 2. That is 7 minus 5 plus 2. This is plus 2 and this is plus 2. So it means the charge has been balanced. So how do we show that we added 5 electrons? We just say plus 5 electrons. So in this case, we have balanced the equation in terms of the atom and also in terms of the charge. Again, we first balance the equation in terms of the atom. We have 8 hydrogen atoms here. So we have 8 here as well. We have 4 oxygen atoms here. And then we have 4 oxygen atoms here. The manganese, Mn is just 1. And then there's only 1 Mn here. So the next is to balance the charges. So the charges, there is minus means minus 1. And then 8 plus here means plus 8. That is, there are 8 plus charges. So 1 minus charge and 8 plus charges. So when we add them together, we have plus 7 altogether at this side. At this side, we have only plus 2. The water does not have a charge. So there's plus 2 at the right hand side of the equation, and then there's plus 7 at the left hand side of the equation. So we balance charges by adding electrons. And remember, 1 electron means minus 1. So when we add 5 electrons at this side, it means we add minus 5 at this side. So 7 minus 5 equals what? Plus 2. So here we have plus 2, and then we have plus 2 at the other side here. And then the equation has been balanced by adding 5 electrons at this side. So we balance the equation atom-wise and charge-wise. Potassium manganese 7 will act as the oxidizing agent, and ethanol will act as the reducing agent. So the IGCSE wants you to show the equation of the reduction of manganese 4 ion into manganese 2. And then there is also color change in that reaction as well. They want you to show the color change as well. The manganese 4 ion is purple, that is KMnO4 is purple, that's the color. Once it undergoes reduction with the ethanol, manganese 4 ion will be reduced to manganese 2 ion, and manganese 2 ion does not have color, so it's going to be colorless. So what you are going to see to show that reaction, that is to show that ethanol has been oxidized to ethanoic acid, or to show that manganese 4 ion has been reduced to manganese 2 ion, is color change. The color will change, that is the color of manganese 4 ion will change from purple to colorless. So the second way of making ethanoic acid is by fermentation, just like the way of making ethanol last time. And this is a biological way. So this one does not need any equation from you. They just want you to let them know that when you leave ethanol standing in air, the bacteria in the air, they bring about the oxidation. So bacteria causes ethanol to undergo oxidation to become ethanoic acid. So this method is called acid fermentation. Acid fermentation is used to make vinegar. So anytime you use vinegar, you are using dilute solution of ethanoic acid. So by fermenting food like apples or rice, you get ethanol. And ethanol is then oxidized further to become ethanoic acid. So that is a way of making ethanoic acid. So thank you for listening. We are going to continue in the next part of this series.